The Deephaven engine is organized to work with many different sources of data. For example, you might integrate a Kafka stream, or receive data from a custom real-time application, or even another Deephaven worker all across the country. With the Deephaven engine, you can then join or merge this data with other formats like CSV, Parquet, or Arrow. Right now, I'm going to show off combining streaming data with Parquet data. The first thing I'll show you is how to import the Kafka stream. To do that, we use Redpanda because it is an easy and fast Kafka-compatible streaming source that has a built-in schema registry. Now, behind the scenes here, I have a publisher that's sending data, crypto data, to a Redpanda topic. In Deephaven, I consume to that topic using the Bootstrap servers and the built-in schema registry. I am consuming the trades topic as well as the quotes topic. Now, I'm using the Avro schema, which I have defined to have a trade schema and a quote schema. Quotes will have the bid and ask and things like that. Now, in Deephaven, we have a lot of options. One of them is all partitions seek to the beginning. And what this does is it goes all the way to the beginning of the partition and pulls in all of that data. The default value is table type stream. I want table type append because I want to see all of that data as much as I possibly can, because it's pretty awesome when we get a whole bunch of data. So I'm going to run the commands, and here you can see I have two tables that pop up. I'm going to put them side by side so we can really see what's happening. We can see that the trades table has almost 1 million rows of data streaming in real time. Now, that's pretty impressive if you ask me. Now, I'm going to combine this with some Apache Parquet data. Parquet is one of the most popular formats for on-disk storage. It has some great features for big volumes, and I encourage you to check it out if you haven't already. To read in the Parquet data, I'm going to read in two different tables of Parquet data that are located on my drive. Execute those, and we can see now two more tables pop up. Again, I have a trades table and a quotes table. I'm going to put them in their respective spots, and you can see nothing is happening with that table. Meanwhile, in the background, my Kafka source tables are still chugging along. Now my trades has well over 2 million values. So, like I said before, the real power comes when we can merge the data into one. And so I want to combine these so that I have one trades table and one quote table. So, again, I have a simple line of a command for each one of those. And now, both of my trades and my quotes are merged. So we can see that my Kafka table is now up to 2.2 million. My Parquet trades is 1.7 million. And so the trades table, which is both of them, no surprise, is 3.9 million. That's all the data coming in continuously, updated as soon as that Kafka stream is being updated. Okay. Deephaven is really cool because the changes are propagated down through the tree dependencies. It just happens. Users never have to really think about it. Now, merging data is just one of the table operations. Let's look at another. Let's do a join. Rather than show you a relational join, like a classic SQL one, we're going to do a Deephaven time series join. Now, in many cases, you want to bring information from one table to another based on the time. This is a perfect use case. We want to ask the question, what is the quote in the market for that particular trade? Now, there's no reason to expect that the timestamps are going to be an exact match. And so that's where Deephaven comes in, and it does a binary search for the most closely matched timestamp. Anyone can be talented with Deephaven, and it's easy. Here's the query. I have an as of join, and I have 3 keys, 1, 2, 3. This third one, timestamp, is the closely matched timestamp. And we can see, we run it, and now we are combining that almost 3 million rows of data with the quotes table. I'm going to put it side by side so we can watch all of them come in. So the trades table has 3.9 million. Our quotes table has 100,000. And so our trades with quotes, if we look at it, we can see it has 3.6 million or 3.9 million. Now that's a lot of data. And notice that it's the same number as the trades data, but now we've decorated it with a whole bunch of information from the quotes table where there is a match. Okay, well, that's a quick intro to some of the basics of Deephaven Engine. It could do a lot more. This is just the surface. If you have any questions, hit us up on Gitter. Till next time.